Coming, folks. My name's Kendall. You're here at the Kubernetes Clinic. Today we're featuring CircleCI. This is our first Kubernetes Clinic. There will be multiple of these going forward, talking with folks like Angel in the DevOps space around Kubernetes, people that are making software or running services or whatever in this space. So we've got CircleCI on today, folks upcoming like Kinvoke, who's forked container-OS and has taken that running. We'll be talking with folks from HashiCorp and GitLab and etc. So we've got lots of folks lined up. If you want to go ahead forward, Angel, I'm going to call you both throughout this whole thing.
It's all good. Thanks.
Oh, Dave, can you go ahead and launch? We've got a poll for folks.
Yep.
Where are you in your Kubernetes journey? So y'all can go ahead and fill this out. So real quick, while you're doing this, tell you a little bit about Fairwinds. Fairwinds is a Kubernetes enablement company. We offer Kubernetes enablement tooling, services, open source, software. So our bread and butter is people who want to use Kubernetes often come to us and say, hey, we know we want Kubernetes. We don't want to learn everything the hard way. Can you help us? So we can build and maintain the infrastructure, get you from 0 to 60 very, very quickly. We have a ton of automation that does this really in 45 minutes. We don't say 45 minutes because you're going to want configuration. You're going to want customization. So it's going to take at least a couple of weeks to get it tweaked to really meet your specific needs. But really a couple of weeks, we can have you up and running with a production-ready Kubernetes environment. And then we offer managed services ongoing to help you be successful with that over the long term. Also in this space, we have a whole bunch of open source projects for everything from deploying into Kubernetes to watching for deprecated APIs within your setup to a tool that checks the health of your deployments into Kubernetes, all kinds of things. We manage Kubernetes at scale for lots and lots of customers. So we've seen a lot of macro level problems and we have open source in this space. And then finally, we do have a software tool called Fairwinds Insights that, I am of the belief that everyone wants to be running Kubernetes right now. If they could do it securely, reliably, and securely, reliably, and efficiently. There we go. There's a third one. They would be doing so. And so this is a SaaS tool that will actually help you do that with confidence and includes admission controllers and policy enforcement, etc. So that's who Fairwinds is. All of those things boil down to, hey, look, if you want Kubernetes and that's a direction your company's going or you're already there, we probably have something for you. So, and then go ahead.
Sorry about that.
It's okay.
There you go. Look at those.
There we go. Okay. So today, as I mentioned, I'm Kendall. I'm president at Fairwinds. I've been here for 5 years working with all kinds of infrastructure from AWS pre-Kubernetes to all Kubernetes all the time as of about 4 years ago and now on all 3 major clouds. And Angel, do you want to go ahead and introduce yourself?
Yeah, sure. So my name is Angel Rivera. I'm a developer advocate at CircleCI today. But as you can see there, my little bio, worked in lots of different agencies, startups, companies, organizations at different capacities and different roles. So been in the business quite a long time. And yeah, looking forward to giving this talk today on Kubernetes and containers.
Yeah, we thought it would be a great way to get started to pull in Circle. I do just want to say about CircleCI, there are lots of CI tools out there. CircleCI is where we point all of our customers by default. There's a lot of things that it does very well. It makes a lot of this very easy, whether you're deploying into Kubernetes or not. CircleCI has a solution for you for deployment SaaS software. And thanks for being here, Angel. And we're going to go ahead and get started with a relatively high level Kubernetes talk. And I'll turn it over to you and try to interject occasionally.
Yeah, sure. Thanks for having me. It's a pleasure to be here. And just a little background on this talk. And I didn't know this was the first Cube Clinic, which is awesome because I think this is an appropriate talk for, a high level talk for folks who are just getting started with Kubernetes. And let me just jump into a quick agenda. So just going to cover these things here. A little bit about Kubernetes, some skill sets that I have kind of a list that I've gathered so that folks can be successful in their endeavors with Kubernetes. And then we're going to talk about Docker and the container runtime quite a bit. And I'll show a little demo of what I was speaking of. And then we'll just recap. So yeah, the first thing I wanted to talk about was the Kubernetes K8 acronym, right? So when I was going into conferences, I was, seeing this acronym K8, and this was years ago, right? When Kubernetes was just a little baby project kind of coming up in the world. And right, like every acronym, I was in the military, like, oh, wow, what does that mean? And just didn't want to ask anyone because it was like, I kind of should know this, right? But anyway, long story short, K8 just basically stands for Kubernetes. It's an abbreviated version. And the number 8 just stands for the characters that are in between the K and the S in the word Kubernetes. So it's just that simple. The reason why I bring this up is I encounter tons of folks in my developer advocacy excursions or journeys, and yeah, this comes up quite a bit. So just to kind of level set everybody, and I'm also using the acronym quite a bit in this presentation.
It's also worth noting that if you're using K10s or K20s, it's not the canonical version.
Or K16s, that's like doubling up, right? Like,
as the case may be.
Anyway, so the first thing I want to cover is why would you use Kubernetes, right? Like, what is this thing, Kubernetes? And there's a couple of reasons that I've kind of put together. And these are like the legit reasons. Sometimes I hear, oh, well, I'm a tech junkie, so I just got to go in and play with things, which is fine, right? And there's other reasons, like my boss told me to, or, people like Kendall here and Fairwinds, they're like, yeah, we're all about Kubernetes. You should use us, right? But the reality is,
the reality is you should use it. Whoa, you're going to say something.
Yeah, there you go.
Keep going.
But the reality is, some of the benefits, right, like common reasons are development teams want to implement DevOps practices, right, and continuous integration practices. And in order to achieve faster software releases, make their software development practices more efficient as well. And in order to do that, you need tooling. And Kubernetes fits that bill really, really nicely because it's a more modern platform, right, for deploying and hosting your applications in a scalable manner. So if you're looking to implement again DevOps practices or CI practices within your software development life cycles, Kubernetes is a tool that you could leverage to help facilitate those practices. Another reason, this is one of the top reasons I hear quite a bit, is teams want to cut infrastructure costs. And the reason why Kubernetes is good at this or helps with that is because Kubernetes is great at managing resources, right? So if you can get a lot more out of your infrastructure and servers and resources by using Kubernetes. And the reason is it knows how to manage, again, resources, application services, right? And you can actually configure the platform to be very, I want to say smart about how those resources, because not every application or service are equal, right? So how you optimize those services depends on, again, the software that you're running, the way you're running the software, and actually your demands, right? So, but if you're looking to help cut some infrastructure costs, Kubernetes is a tool that will definitely help with that. And this is the big daddy kind of reason, right? Like all teams want their applications and services to be highly available and scale with the demand. So again, Kubernetes manages resources really, really well. I mean, it's basically built to do that. And it definitely helps with, high availability and lending flexibility for your demand, right? So giving you that elasticity that you need to be able to have, the application perform as needed under demand. But this also helps with performance cost savings, right? So you can save a little bit if when you have a high demand, you can scale up your infrastructure and your Kubernetes platform. And then if you don't, when you don't have that high demand, you can scale it down and save some money. So it kind of all ties together. So now that I kind of covered the reasons why Kubernetes, let's talk about a little bit of introduction into Kubernetes and what it is. So this is a definition that I pulled off the web somewhere, but you can read through it. But at the end of the day, what I want you to focus on, especially for this talk and actually for the future, is the fact that Kubernetes, is a very robust but complex platform, and that's kind of what gets people to a frustration level, right? After they start looking into it, they start seeing that, wow, this is a pretty massive platform, and it does a lot of things. But at the end of the day, at the heart of it, it's an open source container orchestration system. And again, focus in on open source container orchestration system, because without the containers, Kubernetes is basically a bunch of services running and not doing anything but managing its own Kubernetes, right, infrastructure. So again, just focus in on it's a container orchestration system. And if you kind of learn that and that becomes your mantra, I believe Kubernetes will become a little bit easier for you to learn, understand, and then ultimately operate. So before we get into like where we are today, I always like to take a few steps back and talk about how we kind of got to where we are today, right, with containers and Kubernetes. So back in the day, we used to deploy applications onto bare metal, bare iron servers, right? So that literally meant a 70-pound server somewhere, right? Putting it into a rack, setting up electricity, network switches, fiber, whatever it is that, however you connected your servers, right? And then you installed an operating system, and then you installed your application, configured it, and that was it. And that worked really, really well until you had to add more resources, right, to your setup there. There you go. Basically,
Full environment, all the resources.
Traditional environment, right? Gee, sorry about that. Okay, I thought I put in airplane mode. Anyway, so we have this traditional deployment, right? But as you can see, that's going to be, very cumbersome, expensive, right? Because you have to add hardware. And then we, as engineers, got really, really smart. And what did we do? We created a way to leverage managing resources on that same server a hell of a lot better. And what we did was, if you look in the middle there, the virtualized deployments, what we did was added a hypervisor, which is basically a piece of software that manages the resources between your application and the underlying operating system and hardware. So what that gave us was isolation, right? And then also another mechanism for us to efficiently and optimized manner operate our application without having to, lose or at least expend waste resources on the hardware. So with the hypervisor, we basically packaged up our application. But as you can see in that virtual machine packaging, right, you still had to install an operating system, then your binaries and libraries, and then your application. So you're running like isolated instances of your application, but you still have that heavy lifting of, the operating system, where the hypervisor can kind of take some of that load off of the underlying hardware and manage it a little bit better. But you're still running, pretty expensive layers in that virtual machine. And you fast forward to today, where we're running in what we call a containerized environment. What they've done is basically created this runtime container. So if you can see, the hypervisor has been replaced, the container runtime has been implemented. And what that does is it enables us to manage the underlying operating system of the hardware as well. And what I mean by that is, you have basically kernels that are driven or that are driving your application. And what those container runtime does is it basically shares and manages the underlying kernels for your operating system. So you don't have to create with the hypervisor, you're creating new kernels, right? You're managing multiple kernels, whereas the container runtime just manages what's there, right, in the underlying operating system. And then it can just share those resources a lot more easily. So that makes everything a little bit more lightweight. You don't need that underlying operating system or kernel. And then you can package up your application with basically the bare bones of what you need to get up and running. So I hope that was a,
yeah. Can I add one thing to that, Angel?
yeah, sure.
This is your talk, and I'm sorry that I'm just going to interrupt you.
Nah, go for it, man.
So, I mean, in traditional deployments, you had to maintain that hardware. You had to shut the hardware down, install your application, reconnect the internet, make sure it was all working before you did that, then turn it all back on. You know, virtualized deployments, it took forever to rebuild the machine every time you deployed it. We used to have, like, you know, hour-long deploy processes. We were super excited if we got it down to 20 minutes. And with containers, everything's also much, much faster because all of this has become so streamlined. And if there's a long, long time between every time you deploy, especially if you have a problem once it's deployed, it takes forever to fix. And so that's another advantage of this, is it's really sped up all of those things.
Right. I mean, just if you go back to the traditional, I used to have servers, right, or applications and services for clients, and we would get bursts of, like, let's say we were doing, in Iceland, we were doing a ticket management system, right? And of course, our first foray into our first event, it just blew up, right? And we didn't really know back then how much resources we were going to need. It took me 30 days to get new hardware. And then, right, another probably 2 weeks to get it all configured, set up. So you're going from 2 weeks to literally seconds with container deployments.
Well, and it's one of, you mentioned scaling, but when you have a traditional hardware setup, you have to maintain enough hardware for your Black Friday event, whether or not most of the year you're running at 5% of that. And the ability to scale and match your spend to your actual usage is a big deal.
For sure, for sure. So, yeah, so now that we kind of covered deployments and my phone stopped ringing, we're going to go ahead and talk about Kubernetes. I'm going to do a little explanation of the core elements of Kubernetes so that folks kind of understand the architecture, or at least have a high level understanding of the architecture. And I'm sure that Kendall and Fairwinds will have many, many more Kube clinics that can go deeper dives into this stuff. So let's talk about the highest level component, which is what we call the Kubernetes cluster. As we all know, I'm sure we all know that the cluster is just an amalgamation or a grouping of machines that are working in unison to provide a service. And here's a quick diagram of like what Kubernetes looks like. And if you look to the left, you have the Kubernetes control plane, which is basically the actual Kubernetes platform services, right? And what they do is, the control plane does is it manages the other nodes, which are other computers. So if you, or other servers or computers or resources in the Kubernetes cluster. So if you look to the left, that's the primary node, control plane primary node. It's kind of similar. And then to the right, you have 3 other nodes or servers that are part of that cluster. So in total, we have, if you were looking at it like, let's say a traditional hardware deployment, it would be 4 servers, right? Or if you're in a cloud, it would be 4 compute resources. And one of them is the Kubernetes kind of master, right? So again, just talking about primary nodes and the control plane, just remember here that the control plane is basically the brains of Kubernetes, or it is Kubernetes, and it controls all the little worker nodes within the cluster. Here's another kind of example, but this has a little bit more services. So, right, Kubernetes is an API first concept, or built on the API first concept, which is really nice because you can, you know, programmatically control Kubernetes, unlike some of the earlier platforms that I've seen before. APIs were not really, like, API control over systems wasn't really a thing, or not thought about. But obviously today, with microservices and other platforms, it's a lot faster to and easier to manage systems and services using code and APIs. So what we have here is, right, primary node again, and then these are some of the services that Kubernetes has, and there's a bunch of them, right? So if you even go deeper into these services, there's even more controllers, more kind of disparate services that all kind of work together. But what I want to focus on is on the right side, in the nodes, we have this container runtime, right? And what that container runtime does is enables you to orchestrate what? Containers, right? In Kubernetes. And obviously, if you're going to do that, you're going to need that container runtime. So again, we have that worker node. It's basically where we host our containers for the most part, right? It's where your applications live. And when you have a grouping of instances of your application running on containers in a node, we call that a pod. And a pod is, again, one of the lowest, I would say, objects, right, or low-level objects in Kubernetes. So, you know, when you get to that level of looking at Kubernetes and dissecting the critical components, pods is definitely like the top dog, or they call it the lowest object. I've seen documentation that says that, but it's definitely the most important of all those objects. So keep that in mind when you're, you know, working with Kubernetes and trying to understand what that infrastructure looks like. Again, there you go, pods, right? Super important. But focus in on learning. Sometimes when I tackle complex platforms or systems, I always like to start at the lowest level objects and then work my way up. It gives me kind of that, you know, sanity check, right? Like, I'm not going nuts here. Is there too many API services? I mean, you saw all those things happening, but I think at the end of the day, just focus in on some of that core things, the things that's actually built for, and then work your way back up to figure out how the other services kind of work together with this. So the final thing I wanted to describe is the container runtime, which I think I did really well early on. So we won't really tap that too much here. But what I wanted to tackle was one of the many conversations that I have with folks who are frustrated with Kubernetes. And a lot of it has to do with, number one, not having an understanding that Kubernetes orchestrates containers. That's like number one reason. The other reasons I'll share here, but here's a nice little list of other skills, and they're not, they're technical skills, but they're not like Kubernetes directly related to Kubernetes, if that makes sense. Well, most of them aren't. So I'm just going to rattle off some skill sets that I believe people should kind of engage themselves or educate themselves on, so that they have a better understanding of Kubernetes and also a better engagement with Kubernetes. So first thing, if you're not performing or working with any kind of DevOps or continuous integration practices, I definitely recommend that you start looking into that for yourself, for your teams, and for your organization. They're basically kind of the disciplines, right, that teams are now investing in so that they can release software faster. And here's some of the benefits that you can get from, you know, implementing these kind of practices and principles amongst your teams. Because at the end of the day, it's all about culture, right? And things evolve. And this is kind of like the next level current evolution of software development. So definitely spend some time and invest in learning a little bit about continuous integration and you know, DevOps practices and principles. Security is actually one of those soft spots for me. I've been in this business a long time, and I can tell you I've seen some scary scenarios. So definitely invest some time in understanding security, specifically roles-based access controls, which is one of the key security concepts within Kubernetes. And Kendall, you did mention that you have some sort of tooling or open source tooling that Fairwinds develops and maintains.
So we have two tools in this space. RBAC Manager is the main one, and that's because we've realized with, you know, again, running lots and lots of clusters across lots of clients that people struggle with managing role-based access control at scale. And so having a simple tool for managing that, tweaking that, updating that, et cetera, is huge. Now, the reason role-based access control matters, just a really practical example, we had a customer a while back, we built the entire environment for, and they weren't using any role-based access controls. So everyone on their team had the same access. Well, they had an engineer quit, and they had to tear down the entire cluster and rebuild it from scratch so that that person who had left the company no longer had access to it. And if you are using role-based access controls, you simply change a small setting and that person no longer has access. So
right.
it sounds obvious. It should be obvious, but it is difficult enough if you're new to Kubernetes and RBAC that, there's tooling to make that easier.
Right. And this was an issue early on with Kubernetes as well. I mean, these were like bolt-ons. Some of those features are bolted on after the fact, which is, expected when you have a young project, which I've seen it come, I don't want to say full circle, but I guess it's full circle now. So yeah, but definitely, you don't have to be a CISO or something like that. Just understand the fundamentals so that when you don't get frustrated later down the road, right? Kind of future-proof, like Kendall was just saying, future-proof your infrastructure so you don't have to tear it all down and rebuild it. Because it can be unforgiving if you don't consider these things.
Yeah, I mean, there's reasons to tear down your infrastructure and rebuild it. Don't let access be one of those reasons. Use RBAC.
Yeah, for sure. So networking, Kubernetes, obviously, right? You saw that you can run multiple applications and pods and all that good stuff. Kubernetes has a kubeproxy service that handles basically all of the networking. So that what that means is once your application stands up, Kubernetes is smart enough to know, hey, I need to give this thing an IP address. I need to give it connectivity, because otherwise, what's the point? Definitely have an understanding of networking fundamentals. Again, you don't have to be a network kind of engineer or guru, but you should understand basic network traffic, routing, DNS, domain name services, how those things are how they work. Also, even just basic like network packets, what they are, what they do. Again, don't have to be an expert, but have that fundamentals, because it's really important in this platform. Monitoring and logging is very important. We're developers. I'm assuming we're all developers. And when you're a developer, you're used to kind of sifting through logs, debugging, right? Setting up monitoring helps with debugging within Kubernetes. So, when you're deploying applications to Kubernetes, it's not that solo local environment that you're used to. It's a much bigger platform. So definitely get to understanding how monitoring works within Kubernetes, because it will save you tons and tons of time when you have to debug and troubleshoot.
And I'll add, we have another tool in this space. If you're using Datadog, we have an open source tool called Astro that manages your Kubernetes monitors based on the state of the cluster. So
cool.
Another open source tool.
Yep. Persistence and storage. So, in general, containers and the way we deploy them, I think this is like the industry kind of steers towards being stateless, right? So that means you're not saving anything. It's just something, a service providing things. Of course, you're saving, but within the cluster, generally, you don't run databases. That's kind of like the norm. I have my own opinions on that, but I'll share that later if anybody's interested. But just understand basic storage, right? And how Kubernetes can connect to like the different block storages that different providers have, especially in the cloud space. I see a ton of folks have some frustrations with that, and it varies between the different deployment I would say mechanisms, or how you deploy your application or your Kubernetes clusters and your containers, but just have a basic understanding of how that manages storage. APIs, I think I don't need to say much here. We use them all as developers, so no different here. But again, I would just focus in on the Kubernetes API and figure out, just have a basic understanding of what's going on there, because it will definitely save you some pain later on down the road. YAML, really big one here. YAML's kind of the de facto cloud native syntax these days. You don't have to be an expert, but you should understand what YAML is. It's a data structure, not a programming language. So keep that in mind when you're, sifting through Kubernetes manifests or configuration files. They're generally built in YAML, and yeah, it'll save you some time there. Infrastructure as code is another skill that, outside of Kubernetes will help you in your career as well. It's becoming more and more common that, you need to have at least, a little bit of skill or understanding of or experience with infrastructure as code. That helps with managing your infrastructure, right? So remember when I was talking about elasticity, infrastructure as code is kind of like one of the vehicles, right? That will help you provision, configure, and manage existing infrastructure via code instead of having to go into like a web GUI and, standing up new infrastructure. You definitely want to keep an eye on infrastructure as code and invest in some of that, not only for your career, but also for your infrastructure. Trust me, you will not regret it.
Well, when you've stood up your whole infrastructure with a GUI, it's great, it's convenient, then that person leaves the company and nobody remembers what buttons they pressed. If you keep it as code, it's also documentation of everything that's there, which is a big deal.
Well, the other piece to it too is imagine if you have tens and thousands of servers, right, or clusters even of Kubernetes, and how do you manage that in a GUI? You can't, right? Like, I don't care if you have 10,000 people just focused in on that. It's going to be a bear to and very expensive. So with infrastructure as code, you can deploy these things and manage them. Let's say you need to make a change to all 10,000 clusters. You can do that right through code really easily by just changing a setting, just like Kendall said earlier on, and it will propagate over right to everything. So just keep that in mind. This is really important. I think it's one of those skills that will not only be effective in Kubernetes, it also can cascade into other roles that you're going to be involved in the future with technology. So finally, let's have a deep understanding of containers, which is hopefully what you'll gain a little bit of knowledge from me today on this topic. So right now, Kubernetes kind of defaults to Docker as a runtime. Docker is an open source platform. I think there's different flavors of Docker. So if you're in an enterprise, you can pay a little money and get some support and other features from Docker. But the main community version of Docker is basically an open source project that everybody can contribute to. And it is the runtime. When I say container runtime, Docker is that container runtime within Kubernetes. Docker, here's a definition for you real quick. But what I like to tell people is Docker is a way to package up your application into that, right, Docker image that then you can deploy into any kind of operating system or platform like Kubernetes that enables you to, use your application or run your application in a isolated manner without having to have all those other underlying bits, such as, right, if you have a container built for Windows, you can deploy that right to that Docker runtime, and it will run what's happening there. So let's see. Go ahead.
I'm going to add one thing there. I have a former engineer who used to say to me, Linux containers have actually been around for a very long time, particularly
yeah, for sure.
LXC, right? But the way he described it always was Docker took a concept that was otherwise impossible to understand and made it consumable for mere mortals. And I always find that a good description.
I sometimes say basically what Docker has done was created a wrapper for LXCs, things that have been around forever. I think zones in, is it BSD or Solaris? Anyway, it's a long time. But anyway, there's every NX operating system has its own version of this. But it's basically a wrapper. And actually, you'll see this in a second. I'm going to talk about some of the core elements of the Docker runtime, which are basically, in my mind, I just want to boil it down to, at least for this level, 3 critical kind of components, which is the Docker engine And again, it's the Docker engine and Docker runtime are synonymous, right? They're the same thing when I talk about that. But I've been using the Docker images from the Docker website. So we're going to call this the Docker engine / runtime. And this is a nice graphic because you can see here, if you look at the blue blocks on the edges, the Docker API is another way to basically, control the engine and interact with, programmatically interact with the Docker runtime. And then you have the Docker CLI block there. That's basically a CLI tool, which I'll demonstrate a little bit later. That's kind of a manual way. This is how we develop software, develop our containers, build them, right? Using that infrastructure or that Docker CLI tool. And then you have your plugins, which is basically, extensibility. You can, if there's something that you want that Docker engine to do, you can create a plugin and then you'll have that. So the next core component is Docker images. So what I like to use as an analogy for Docker images is you can think of a Docker image as a cookie cutter, right? When you have a cookie, like Christmas time, I don't know. I think there's a star cookie cutter in my kitchen somewhere. I really don't like it, but my wife uses it for Christmas, right? Anyway, so the Docker image is like a cookie cutter. And imagine if you rolled out some dough on your countertop and, you're going to start making cookies. You want them to all kind of at least try to be the same, right? Look the same and have the same shape. And that's what a Docker image is. It's a template for your container. So if you take that container or that Docker image or that Docker cookie cutter and you smash it down, right? And maybe it's a whale shaped cookie cutter. Let's use that example. And you want, your little whale shape Docker containers or Docker images. So as soon as you smash that cookie cutter into that dough, you've just created a let's say a cookie, but it's also a container, right? You spawned a new version or you spawned an application, a new version of your application in a container format. So I hope that that analogy or that vision works for you all. Think of images as just templates, right? And the way that you create an image is by using the Docker build command. Now I'm just highlighting some of the CLI commands. The more common ones you're going to be using, which are Docker build. This is the main one, one of the main ones. And what it does is it builds your image based off of what we call a Dockerfile. And here's a good example of a Dockerfile. Really simple, right? It's almost like, I want to say YAML-esque in a sense. Kind of reminds me of YAML. But basically what this is doing is inheriting from a previous image because the Docker engine, the Docker system also layers or caches using layers. So what that means is every one of these commands is a layer, right? So it's almost like you're just piling on things. And the reason why it caches this is to make the system faster, right? So if you don't have to do something, right? So it knows when something's changed, and if you don't have to redo it, then it won't. It'll just say, all right, this is the same, and boom. Only change what's been updated, if that makes sense. So just remember that's how that works in Docker when you're building images. And you can optimize those builds as well. So sometimes when I'm developing something or packaging up my application, if I don't put the steps in the right order, like installing dependencies before copying something, and I only change my package.json, then I'm going to run all that stuff over and over again, and it's just going to increase my time, and I won't be efficient. So just be cognizant of like the longer running kind of operations in your Docker builds. Make them kind of more towards the bottom so that of your file, so that you don't have all those and one rule I use is, if things change a lot, push it more up to the top, and then the longer running processes, push it more down to the bottom. But basically this is what we're going to be using in the demo. So let's jump into Docker containers. So now that we've built our image, that's great, right? And now that image will live somewhere in a registry or repository registry somewhere. Usually I use Docker Hub, which is a really cool service from Docker. And it's basically an online storage for your containers, and it's free. So if you have any open public kind of containers, then you can just store them there in Docker Hub. But once you built that image, and it's living in a registry or repository, you can then start spawning that image into containers, right? So you would do that by creating or running this command in the Docker CLI as Docker run. And Docker run, again, creates and then also starts and stops. Well, actually, it creates your container, an instance of your container. And this is exactly what is happening in Kubernetes, right? So whenever you deploy a pod with containers in it, it's just running Docker run commands on those images, right? That you've kind of templated up and packaged up into that repo or the registry. So again, I covered Docker images, Docker build, and then Docker run. And now I want to show you how to do all that stuff. Does that sound good? All right. Let's find my handy dandy. Let me, oh, that's not. I'm going to plus this up. That good?
Yeah, that looks good.
I'll go one more. Well, one less, I guess. All right, so I have a server that I run. First thing we want to do is, by the way, I'm on a new keyboard, so it might be a little weird, my typing, but I'm pretty bad at typing anyway, in general. So if you ever want to see how many images or what images are on your machine, you could just type like Docker images, and that'll show you, right? I have a few images already. And by the way, when I said layering, this also applies to any other kind of image. So if you have images that live locally and it detects any kind of IDs, it will it will have layers also with SHAs in them, and it can distinguish between the two. So again, it's really optimized to kind of have everything in one place, and you're not continuously downloading, right? It's designed to be very efficient. So you might see like, oh, you already have that, but it was from a different image. Anyway, let me go ahead and CD into my projects folder so that we can build a Docker image. So if I do an LSLA, we have series of projects on that server. What I'm going to do is use that Dockerfile that's there to build my image. So first thing, let's clear this out so we get a clean slate. All right. And then we're going to say Docker build, right? We want to build our image from that application that's sitting in there. And then we're going to say here is Docker T, which is a tag. Docker, this is how you would name your image. And what I'm going to call this is just like Node.js. Let's just call it test. And then from there, we just need to tell it that we want to do we want to specify the Docker file. Remember, I have the directions on how to build this in the Docker file. And then the most important thing here is when you're running this build command, people forget all the time, is this little period dot after that command. That's basically just telling it to execute on that file. Without it, right, you'll just get this weird error message. Anyway, I'm going to run it. And as you can see, when I was talking about the layers, right, every step in that file or every command in that file will become a step, right? And remember, I was speaking about installing packages and stuff. This is step 4, right? So it's going to install all that packages and dependencies my application needs. And it was pretty quick. Now, again, this application is a very small application, but if you have this time will vary depending on the build time will vary depending on what's going on in your Docker file, but they're relatively quick. And
well, it didn't start from installing an operating system, right?
Exactly.
I mean,
right.
Like, if nothing else, that's a big deal.
Right. And then I'm going to show you the Docker image now. So I built the Docker image, right? Node test. So now we have basically we built our template or our cookie cutter for this application. And I put Node.js. All right, great. All right. So now that we've kind of covered that, let's go ahead and clear the screen. And we're going to do a Docker run command. So I want to spawn a new, so this is how you get your application to execute on Kubernetes, right? You wouldn't be doing this, by the way, manually. Kubernetes would be doing this for you as a deployment, which that's a great, Kendall, right? A great Kube Clinic deployments. Anyway, so we're going to do Docker run. But one of the things we want to do is create a container. So this is how you create a container. And we're going to call this, well, we're going to, yeah, dash D is a daemon because we want it to run in the background. You can do interactive things, but I'm going to let you all kind of research that on your own. And then we're going to do something like we have to, since it's a web app, we have to open up some ports so that the ingress, right, from outside can get translated over to my Docker container from from the computer. So let's go ahead and put it on port 5000. And then that's the ingress. And this is the internal kind of ingress, right? So it's almost like a network address translation, but for ports. And what we want to do here is just give it a name, the container, right? So I'm going to say node, I don't know, Node.js app, right? And then we're going to, no, I'm forgetting something here. Oh, right, the image. We got to, so now that we have, right, the port number defined, we have the name defined for our container, we have to tell it which image to use to spawn this new application or this new container. And we're going to just say Node.j and test. So that's basically it. This is how you're going to spawn a new container. And once you created that container, we can do a Docker PS. So it's basically showing you what processes are running within the Docker runtime. And as you can see here, we created this 8 seconds ago, and then here's the state. It's been up 6 seconds. So what I want to do next is show you basically that this thing is running. So let's go ahead and bring this over here. I'll just open a new window, and then we're going to type ub docker 5000 is the port, remember, and that's basically running on my server that application. Real quick, if you wanted to stop it now, right? Once you create that, once you run that Docker run command, you can do things like Docker stop, and then what is it called? Node.js app. And that will stop the application. So if I do a Docker PS, I have nothing running. But if you do a -A, it shows you all of your containers. And this is in a stop state or it exited, right? So again, you could just run Docker start. Oh, of course, you have to tell it what to start. So, and that's a Node.j. Oh, what's that? Oh, of course, because there is no Docker. It's just Docker. Told you I was terrible at typing. Anyway, so let's see. There you go. And boom. Now you do a PS again. And you have your application up. So basically, that's it. Let me jump back over to the deck. And yeah, so oh, that jumped for me. All right, so that was the demo. And now just jump into a recap because I want to get to some questions from everybody. So here's some commands, right, regarding images. So, you know, get to know these commands, really important that you understand Docker, understand containers, how that whole runtime works. Because again, right, Kubernetes is just orchestrating and running all of those things for you. The next thing you would definitely want to understand is containers and how it runs. These are the more common commands that you need to be familiar with, right, to help you understand. There's definitely a ton more, but this is always a good starting point, at least for me and the people I work with, you know, to get them started understanding the runtime. Obviously, the skill sets that I spoke about earlier. Please don't take this as like you must be a master at all of these things. Again, just have an understanding. And as a developer, you probably already know most of this stuff, but there are times where, you know, some developers do all kinds of work and they don't really understand certain concepts and aspects or don't have experience with it. Definitely just, you know, understand these things, and I truly believe it will help you, you know, with your Kubernetes endeavors. Here's some resources for the community, for the folks that, you know, want to learn more. The top three ones there are obviously the Docker CLI, but the other two in the middle, MicroK and Minikube, these are like local environments or tools for that you can develop or install and run Kubernetes locally. So a lot of developers use these tools to easily like run things locally instead of like standing up multiple, instances of infrastructure. I've used Minikube and MicroK in my learnings, and I still use them. They're great tools. So definitely take a look at that. And then the community resources that are out there from the Kubernetes site is also really good. Yeah, so this is my favorite part of all these things is the questions section. So
in Zoom, bottom right, there's a little Q&A section down there. You can go pop in and ask questions.
Oh, that's not it. But
I will address, I feel like every time we do one of these, somebody asks, should I run my database inside of Kubernetes? And Angel, you touched on that. Talk about why you don't suggest that, and I can maybe add something in while we wait for other questions to.
Well, right now, I think the reason why people I would, well, all right, let's talk about my experience doing that. So Kubernetes is great. So think about the architecture. It's great for being efficient and managing applications in a stateless manner. But once you start spinning up databases and actually not only databases, but like just applications or systems that are really heavy with resources, like networking and the block storage or persistence that I was talking about, right? So if you have systems that use high networking or high IO, your system is now going to compete with the other applications that are running on that same cluster. And unfortunately, there's not unlimited bandwidth or IO for disk. And those are the biggest problems that we have. You would think it would be memory or something. It's not that. It's literally the machines are sharing all of those resources and they're not fast enough. So I would recommend dedicated persistence resources. So meaning, keep your MongoDBs or your Postgres or MySQL systems separate because you can manage those a lot better. And they're really critical to a lot of these systems today, right? Everything's being saved. So you need that basically super highway throughput to get that data back and forth between the systems. Whereas Kubernetes, you're just running an application. And yeah, of course, you can add more resources to that cluster. But your database, which is really important, right? It's going to be your bottleneck. So it's almost like, you're just bottlenecking things.
Yeah, I'd add to that, like everything in Kubernetes world is built to be ephemeral. In theory, you can run a database in persistent sets or stateful sets, whatever they're called, stateful sets, and have long-lasting data there. But if you think of everything in Kubernetes, including the cluster itself, as ephemeral, which is even the way that we suggest doing upgrades, is to actually I think that's still what we suggest. But actually tearing down the cluster, standing up a new one, and shifting workloads over. If you can, in theory, disconnect the database from an existing cluster, reconnect it to the new one, but there's always going to be race conditions, delays, problems with that. It looks good on paper. It doesn't work real well in practicality. And then, you also have to manage your own database, which if you can give it to something like RDS or something else, it's real nice. But
yeah, one of the things I've experienced was running that like a database on Kubernetes with my, serving up that persistence layer. And one of the things was configuring that, right? So Kubernetes will self-heal. It will destroy, stop containers. That's how it works, and then bring up new ones so that your elastic, your system is running, high availability, all that good stuff. But the problem is it doesn't know how to connect back, or it's difficult to configure that to connect back to that same data store.
Yeah.
And then if that data store goes down, and yeah, there's a lot of problems with it. So I think it's a suggested practice that you keep it separate.
Yeah. So we've got just a few more slides, and we do have one more question. So Angel, a real quick answer: how do MicroK and Minikube differ?
Yeah, so I stopped using Minikube for a while now, and I've been using a micro K8s, which it's built by Canonical. It's an open source project, and it's a really cool tool that you can deploy into Ubuntu, which is the distro that I use quite a bit. The main difference is it's even, in my opinion, it's even easier because it just kind of works, right, with the operating system, and it's a super simple setup. Whereas Minikube, you still have to configure things, which is fine. For me, I don't have a real preference one over the other. I just use micro K8s because I use Ubuntu.
Yeah. Okay, well, let's go on to just a few things here. So Fairwinds has a whole bunch of open source that we mentioned previously. Rocket Scripts is a tool that we have for this opinionated scripts for handling the full life cycle of applications getting deployed into Kubernetes. So this works well with CircleCI. You can plug it into anything, but it will work with CircleCI. There's a link to an orb here. CircleCI has a concept called orbs, and we have integrated Rocket Scripts into the orb. So that's also available if you're using CircleCI and you want a simple way to deploy into Kubernetes. This makes it easy. And it's a very powerful tool if you need to get into some of the nitty gritty of what you're doing in that deployment process. And then next, we've got one last poll here before you go. What are your biggest challenges to deploying Kubernetes? This is helpful for us to know. As a company, I'll share the results if everybody fills it in. And then you can go ahead and go on to the next slide here, Angel, while we wait for the poll to fill. So these are our upcoming Kubernetes clinics. So the next one is the Kinvolk folks. As I mentioned, these folks forked CoreOS when it stopped being supported and renamed it to Flatcar, and they offer supported Linux distribution for that. So they're going to be talking about that. After that, we're meeting with Datadog folks to talk about service reliability through auto-scaling workloads on Kubernetes. And then November 12th, we'll be talking about a bunch of the open source tools that Fairwinds has with our open source director. We have a few other things going there. Finally, if you are looking at Kubernetes and you want to have a quick assessment, this is a tool that we have available that you can use. It will talk about some best practices in Kubernetes, help you dig through, look at how you fit on a maturity scale, et cetera, and get you started in knowing, am I doing this right? The biggest problem in security is misconfiguration. And I think the biggest concern for SREs, engineers, even leaders is, are we doing this right? And are we listening to the right people? And this is something that'll help you answer some of those questions. So see if
that's the last slide, yeah.
Yeah, that's the last slide. Do we have results from the poll here, Dave? Let's see, maybe you're sending them to me in the background. So let's see. I don't understand, Dave. It's okay.
So I'd say 50% was getting to production, and then it was split between complexity and finding expertise and lack of skills.
Okay. Yeah, I think getting to production is hard. If you need help, look us up. There's great tooling out there. Thanks everyone for joining us. Angel, we really appreciate you putting us on. And
thank you for having me. And in the future, I'd love to do some more of these, like CI/CD, show it off, how you can deploy things, and that'd be pretty cool.
That'd be great. We'll have you back. Sounds good.
Yeah.
Thanks, sir. And thanks everyone. Have a great day.
All right. Thanks.